Hi, my name is SASITHAREN and I will be talking about introduction, objective and theory. So for the introduction, the generation of electrical power is a fundamental to modern civilization. Relying on rotational motion and magnetic field, these principles are key in the system like hydroelectric, wind and thermal power plants. Understanding their interplay is crucial for optimizing efficiency. So for the objective, understand the rotational motion, explore its mechanism and application in power generation, examine magnetic field, investigate their properties and role in electricity generation, analyze interaction, study how rotational motion and magnetic fields produce electrical power, apply knowledge, relate to the theory to real world system and improve performance. So for the theory, rotational motion, movement around an central axis typically produced by turbines. Key parameters: angular velocity, angular acceleration, and torque, which determine turbine efficiency and output. So for the magnetic field, a vector field exerting force on moving electrical charges and magnetic dipoles. Role in power generation: induces electromotive force in a conductor moving through field based on Faraday law. The interaction will be mechanism. For the mechanism, turbine-driven rotors spins within a magnetic field, introducing EMF, which is an electromagnetic force in stator winding. The output will be generating an alternative current, which is AC, or direct current, which is a DC, depending on the generator design. The optimization will be enhancing the efficiency, involve adjusting the magnetic field strength, rotation speed, and generator configuration. By mastering this concept, engineers can design more efficient and reliable power generation system. Thank you.
What can we discuss from our project? First is the interpretation of the results. So the experiment validates the Faraday's law by demonstrating that the induced voltage is proportional to the rate of change of magnetic flux. Second, the rotational motion serves as the driving force for mechanical energy, which converts into electrical energy through magnetic flux variation. So the correlation between the speed and the output is the higher the rotation speeds, the greater the electromagnetic force, and vice versa. So we faced some challenge during the testing, which is the voltage regulator failure, which is the LM7805 regulator burned out during our initial test, likely due to the overheating. So replacing the component resolves this issue. Second, the inconsistent rotations, which is the manual pedaling inconsistency, cause the voltage fluctuation, affecting bulb brightness and charging efficiency. So what we learned from our project is the project demonstrates how rotational energy and the magnetic flux interaction can be harnessed for practical power generation. The small-scale application like charging devices during cycling or outdoor activities can benefit from this technology.
Okay, now I will explain for the procedure part. Okay, in this project, it is not too complex to create a prototype to explain the effect of rotational motion on the magnetic field. So this is have 6 main components. The number 1 is brush DC electric motor. We use 2 DC motor. Number 2, switch. Number 3, shaft coupling that we use to connect to DC motor and the shaft DC motor. And then number 4, connector wire that we use to point. And then we use a PVC form that we use for a base of prototype. And then number 6, wire for connection every component. So in this part, the equipment we use, first multimeter digital that we use for see the output at the second DC motor, and then DC power supply that we use to supply at the first DC motor, and then we use DC power supply because we want to control the voltage and the current in. And then for the load, we use the lamp. It's up to you. You want to use what load. Okay, now I explain the process to make the prototype. First, I prepare the component that will be used and I test each component to ensure that it is in good condition. Okay, and then we start with the prototype base. Here, we are using a PVC form. You can use any suitable material in this prototype. The size that will be cut for the prototype base is 29.5 cm for the length, and then 3 cm for the wide, and we use the PVC form 2 mm thick. Size will be around like this. Okay. For 2 point for wire connector, and then the supply will come in over here, and then we use switch to control, and then we solder the first DC motor. So in this part is for resource for the rotational on the second DC motor. Okay, for the second motor, we must separate the first. Okay, this one the rotor in the DC motor. and then this one I have a connection wire over here and the brusher, and then this one housing for the DC motor, and also the component housing for the magnet. Okay, and then for the magnet I will make connect to be like this, so easy to you make it close into the rotor to see the effect of the rotational rotor and magnetic field. Alright, and then we use shaft coupling to connect two DC motor. Here we test with the two DC motor. The first DC motor we supply by using a DC supply power that will control the current and voltage, and then the second DC motor we get generate voltage from the first rotational the first DC motor. So you can see here we test the prototype. So you can see when I start to close the magnetic field into the rotor will cut flux in the magnetic field, so the voltage will increase when I close into the rotor.
Assalamualaikum warahmatullahi wabarakatuh. My name is NABILAH binti Ahmad. My matric number B022110078. So for the conclusion and recommendation, first, the magnetic field in DC motors plays a crucial role in converting electrical energy into mechanical energy. Next, the study highlights how factors like the magnetic field intensity, direction, current flow, and design elements such as pole positioning or material and winding design directly impact other performance, efficiency, and durability. And the last one, it also emphasizes the importance of ongoing innovation in materials and technology to create more energy efficient, sustainable, and advanced motors, especially as we move toward the renewable energy solutions. That's all from me. Thank you.